will discuss about total internal reflection. Now in the last class, in the last video, I told you about the critical angle, and depending on that critical angle, on the conditions that whether the angle of incidence is greater than critical angle or is less than critical angle, we can decide that whether the total internal reflection will take place or not. Firstly, let us understand this term, that is total internal reflection. What is it? When the light ray, it travels from a denser medium, it travels in a denser medium and makes an angle of incidence. This is our normal. So if this incident ray, it makes an angle of incidence greater than the critical angle. I'll read it for you. What is it? When the light ray is traveling in denser medium, suppose this is our denser medium, it might be glass, diamond or anything, and this is our rarer medium, that is, suppose it is air. We just take an example of it. The rarer medium here is air and the denser medium is water or glass, anything. So if the light ray travels in the denser medium and is incident at the surface of separation, this is our surface of separation that separates both these mediums, water and air. So if this light ray, incident ray, strikes the surface of separation and makes an angle of incidence, obviously this is our incident ray, it will make an angle of incidence with the normal. So if the angle of incidence is greater than the critical angle, you know about critical angle, it is greater than the critical angle for the given pair of media. Here the given pair of media is water and air. It can be anything, it can be glass and air or diamond and air, anything. So for the given pair of media, then the light ray is reflected back in the same denser medium, in the denser medium. So here the denser medium is water. So the light ray, it is totally reflected back in the same medium, in the denser medium only. You might think that, sir, why are we using this term here, total? Because the light ray here, it is not being refracted or not being absorbed at all. The 100% intensity of light, it is being reflected in the denser medium. That is why we are using the term total internal reflection. You might be asked that in binoculars or in periscopes, we use a prism in the place of, instead of using a plane mirror. Obviously you know about plane mirror, it reflects the light ray, but if we compare both of them, the plane mirror and the prism, then the plane mirror, there might be possible, it might be possible that some intensity of light ray is being absorbed there in the case of plane mirror. But if we use a prism in the place of plane mirror, then 100% of light ray, it will be reflected back. Total internal reflection will take place, and that is why in periscope or in binoculars or in certain cameras also, we use the prism instead of using a plane mirror. It might be asked to you. So this was the basic part about the total internal reflection. Now we will discuss about if the total internal reflection is taking place in the prism. So we'll discuss about it. What is the case when total internal reflection takes place in a prism? Basically, we will discuss about three types of prism. One of the prism, it will be right angled isosceles prism. Our topic here is total internal reflection in a prism. And one more thing, if you are asked that what are the conditions that should be fulfilled for total internal reflection taking place, you know about it. The light ray, it has to travel from optically denser to rarer medium. This is the only case. The light ray, it shouldn't travel from rarer to denser medium. If the light ray, it travels from optically denser to rarer medium, then we'll talk about total internal reflection. And the second part, the angle of incidence, it should be greater than the critical angle. It might be asked to you that what are the conditions when the total internal reflection will take place. So these are the two conditions. You can state them. Now we come back to our topic, that is about total internal reflection in a prism. Basically, the very first type of prism that we'll be discussing about is the right angled isosceles prism. Right angled isosceles prism. Right angle means one of the angles of the prism, it must be 90 degree, and rest of the two angles, they should be equal. The base angle should be equal, that is of 45 and 45. So I'll write the measurement of angles: 90, 45 and 45. This is the measurement of angles of the right angled isosceles prism. In this type of prism, there are three conditions in which we can use this type of prism. The right angled isosceles prism, it can be used in three manners. The very first one is to deviate the light ray by 90 degree. Depending on the purpose, what is the purpose of using this type of prism? Depending on the purpose that we are using this prism, there are three cases. If we want that the light ray, it should be deviated by 90 degree, then we can use the right angled isosceles prism. I'll make a schematic diagram of it. You might be asked to draw the diagram, or you might be asked that how can we use a right angled isosceles prism to deviate the light ray by 90 degrees. So you will draw the diagram. How do we do that? It's very simple to take the incident ray that is normal to the surface. Keep it in mind whenever we are going to draw any diagram, then it is convenient for us to take the incident ray normal to the surface, any surface of the prism. So we have assumed here that the incident ray, it is normal to this face, this surface of the prism, and the angles here are, this is 90 degree, this is 45 and this is also 45. So this is our incident ray. As you can see here, this is incident normal to the surface, so this angle, it must be 90 degree. And you know about it, if the light ray, it is incident normal on the surface of separation, then there is no deviation taking place, so it passes undeviated. Now the incident ray, when the light ray, when it strikes this surface, now we have to find the angle of incidence for this condition, so that we can find out whether refraction will take place or total internal reflection will take place. Now as you can see here, once the light ray, it has entered in the prism, that is inside glass, so now its tendency is to move from glass to air, that is from denser to rarer medium. So now we have to decide this angle, we have to find this angle, that is the angle of incidence. If it will be greater than the critical angle for the given pair of media, that is of glass and air, then total internal reflection will take place. This is 45, this is 90, so this angle must be 90, and this, the rest part, the third angle, it will be also 45. And as you can see here, we have drawn the normal here, so this whole angle, this whole part, it must be 90 degrees. So this is 45, then this angle must be 45. Now, I told you in the last video that the critical angle for glass air medium, the pair of medium, if it is glass and air, then the critical angle for glass is 42 degree. And as you can see here, the angle of incidence, that is 45 degree, it is greater than the critical angle. So obviously total internal reflection will take place. So here total internal reflection takes place. Now, what will be our condition here? Total internal reflection has already taken place. Now, if this reflected ray, it strikes this surface, suppose this is our prism A, B and C. Initially, the light ray, it strikes the surface AB. Now, after total internal reflection taking place, this light ray, it is already moving inside glass, that is inside prism. Now, it has to pass from denser to rarer medium. Again, the condition will be fulfilled. it is passing from denser to rarer medium. Now what will happen? As you can see here, if this is 45, following the law of reflection, this angle of reflection will also be 45. And if this is 45, this is normal, then the rest part, this angle will also be 45. This is also 45. It's very simple. You can do it of your own. So this is 45, this is 45, then the third angle, it must be 90 degree. And obviously if it is perpendicular to the surface BC, it will pass undeviated. So as you can see here, the light ray, the initial path of the light ray should be like this, along this direction. But the light ray, it doesn't move along this direction. It is deviated by this much angle and passes along this direction. So how much deviation takes place here? It is the light ray, it is deviated by 90 degree. It's very simple. This whole part, this whole angle, it is 90 degree. So this was the very first condition in which the right angled isosceles prism is used. Now the second type of case in the same prism will be to deviate the light ray by 180 degree. Now the next case is about to deviate the light ray by or through 180 degree. To deviate the light ray through 180 degree. Now I'll draw the diagram for it also. This is our right angled isosceles prism. This is the right angle, this is 45 and this is also 45. The base angles, they are equal, and that is why we can say that this prism is a right angled isosceles prism. The light ray, again as I told you, it is convenient for us to draw the incident ray normal to the surface. So this is our incident ray, that is normal to the surface, and as I told you, if the incident ray is normal to the surface, it will pass undeviated. So it passes undeviated. Now as soon as this light ray it enters in the prism, in the glass medium, now we have to decide that what is the angle of incidence when this light ray it strikes the surface. Suppose this is A, B and C. When the light ray, after entering the prism, when the light ray it strikes the surface AC, now we have to calculate the angle of incidence here. So this angle of incidence, obviously this is our normal, we can find the angle of incidence. This is 45, this is also 90 degree, this angle it will be also 90 degree. That is why the third angle it will be 45, and it is normal, so this whole part, this whole angle, it should be 90 degree. So if it is 45, this part will be 45 degree. So we got the angle of incidence here, and again it is 45 degree, so it is greater than the critical angle, that is for the given pair of media, that is 42 degree the critical angle is. So again the light ray will be reflected. The light ray after striking the surface AC, it is reflected back in the same medium, in the prism only. So it makes an angle of reflection that is equals to the angle of incidence, that is also 45 degree. Now when this light ray it strikes this surface, again it has to travel from denser to rarer medium. Again we will find the angle of incidence here. So here also, as you can see, this angle it will be also, similarly you can find it, this will be also 45 degree. And if this is 45 degree, again the angle of incidence is greater than the critical angle, so again total internal reflection will take place. And when this light ray it strikes this surface, you can find it of your own, this is 45, and if this is normal, then the whole part, this whole angle, it must be 90 degree. So you can find the remaining part, that is this angle, this will be also 45 degree, and this is 45. So this angle it must be 90 degree, and again it is perpendicular to the surface. So the incident ray, if it is normal to the surface, it will pass undeviated. As you can see here, the light ray it was traveling along this direction. I'll produce it so that it is much clear to you. It was moving along this direction, but when it comes out of the prism, it is moving along this direction. Along this direction. So it was moving along this direction, but after it enters the prism and total internal reflection taking place for 2 times, the light ray, it is opposite to the initial direction. So by how much degree, by how much angle is it deviated, the light ray is deviated? It is deviated by 180 degree. It becomes opposite to its initial direction. So this was one of the cases that we can use in the type of right angled isosceles prism. Now, you might be asked to draw the diagram for it also. Suppose there is an object, then what will be the condition? I'll draw it for you. If this is our object, suppose this is AB, the light ray that is passing through this end A, it goes like this, following this part, and after emerging out, this is our image A dash. And if we also take a light ray that is passing through B, then the same condition, it will be followed here also, and the image for B, it will be obtained somewhere here. This is our B dash. As you can see, it's very simple. The light ray that passes through A, after total internal reflection taking place, the light ray comes here. That is this is our image for A, that is A dash. And following this path, remember to mark the arrows. So this is our image of B, that is B dash. As you can see here the A was on the left hand side and B was on the right hand side. But in the image formation, the B dash, that is the image is on B image, that is B dash, it is formed on the left hand side, and the image of A, that is A dash, it is formed on the right hand side. So you already know about lateral inversion. So here the object, the image of the object is laterally inverted. That was on the left becomes the right, that was on the right becomes the left. It's very simple. Now we move to the next case, that is when this type of prism, right angled isosceles prism, is used to erect, that is, I'll draw the diagram for you. To erect an inverted image, the position of the prism is same as this condition, but the light ray that was entering from this surface BC, now in this condition, the light ray, the object or the image, it is here, the position will be here. So in this condition, suppose this is our object or this is our image that has to be inverted. Suppose this is A and this is B. Now, if suppose this is inverted and we have to erect its image, what can we do? This is one of the light rays that is passing through this end A. As you know, what will be the condition here? It will, the light ray, it will bend towards the normal. So it bends towards the normal, and again, if it strikes this surface, after striking this surface, it will go like this, and in this condition, the light ray, it emerges out following this path, that is like this. And if we have to obtain the image of the point P, then also it has to travel from optically, I'll mention this arrow afterwards. These arrows, they are most important part, you have to draw them. So for this condition, the light ray, it has to travel from optically rarer to denser medium, so it will move towards the normal. Again, now here total internal reflection will take place because the light ray, obviously it will make an angle of incidence greater than the critical angle. Now when total internal reflection takes place, and again here obviously when the light ray it is refracted, it is coming out in the same medium, that is in air, then the condition here will be that, what is the condition here? The angle of incidence, it is less than the critical angle. Now as you can see, this light ray following this path, it emerges and comes at this position. So this is our image of A, that is A dash, and following this path the light ray it emerges out at this position, so it must be the image of B, that is B dash. Now what is the conclusion here? If suppose this object it was inverted like this, and as the image here, the image that is obtained here, it is inverted of this image of this object, so we can use this prism in this manner. By doing so we can erect the inverted image. So this image was inverted and this image is erect. Now you can mark the arrow here. Wherever you are marking the arrow in this direction, in downward direction, it means that the image is inverted, and here the image is erect. So you will mark the arrows here so that it is clear that here it was inverted and here it is erect. So this was the last case, the last purpose that is done, that is used in the right angled isosceles prism. Now the second type of prism, that is our equilateral prism. Equilateral, as the term sounds, equilateral prism, it means that all the angles will be 60 degree. Now I'll draw a schematic diagram for you so that it is clear. It might be asked to you to draw the diagram that how will the total internal reflection take place in the case of an equilateral prism. So all the angles, each angle of this prism is 60 degree. Now, as I told you earlier, for our convenience, we consider that the incident ray, it is normal to the surface. Obviously, the light ray, it can be incident at any angle, but for our convenience only, we assume that this incident ray is normal to this surface. Suppose this surface is AB. So to the surface AB, the incident ray is normal. Now you can find the angles of your own. I'll do this part for you. The rest of the parts, you will do it of your own. This is 90 degree. So obviously this angle should also be equal to 90 degree. This is vertically opposite angle. So this is also 90 degree. This is 60 degree. And the third angle, it will be 30 degree. Now, in order to get the idea that whether total internal reflection will take place or not, we have to find this angle of incidence. Obviously, this light ray, it is traveling inside prism, in the glass. So, it has to travel in the denser medium. Now, when it strikes this surface AC, if it will make the angle of incidence greater than critical angle, then only total internal reflection will take place. So this angle, as you can see here, this is our normal. So this whole part, this whole angle, it must be 90 degree. And this angle, we have found it already, this is 30. So this must be 60 degree. So it is greater than 42 degree. Obviously, here total internal reflection will take place. So this light ray, it will be reflected back inside the prism only. It won't be refracted. It won't move to air. And as you know, obeying the law of reflection, this angle, the angle of reflection, it will be also equals to angle of incidence. That is, it will be also equals to 60 degree. Now, as you can see here, this is our normal. So this whole part, this whole angle, it must be 90 degree. And this angle is 60 degree. So the rest part, it should be 30 degree. This is 30, this is 60. So this angle, it must be 90 degree. As you can see here, if the incident ray, it is normal to the surface of separation, no deviation takes place. It is already known to you. So this was about the case of total internal reflection in an equilateral prism. Now we move to the next case, that is a prism having its angle 30, 60 and 90 degree. It is also an right angled prism, but it is not isosceles. Right angled isosceles prism, it will be only when the base angles will be equals to 45 and 45. But here in this case we have a right angled prism. I won't mention here that it is right angled isosceles prism because the angles here are 30, 60 and 90. So obviously it is right angled because one of the angles of the prism is 90 degree and rest of the angles, they are not equal in magnitude. They are 30 and 60. I'll draw a schematic diagram for you. Here we have the prism 30, 60 and 90. Now for total internal reflection to take place, here we have a special case that the light ray, it has to enter the prism through this face only, through the face BC only. I'll explain it to you in the same video. Suppose we have considered the light ray, the incident ray, to be normal to this surface BC. So it is 90 degree. If it is 90, it is 60, then this angle, it must be 30 degree. To get the idea for total internal reflection, whether it will take place or not, we have again to find the angle of incidence. So if this is 30 degree, this is our normal, this whole angle, it is 90 degree. So the rest part, it must be 60 degree. As you know, it is again this 60 degree, this angle of incidence, it is again greater than the critical angle for glass, that is 42 degree. So here also the light ray, it will be reflected back in the same medium, in the denser medium only. So this light ray, it comes and it strikes this surface AB. Now again we have to find the angle of incidence here, so that we can decide whether total internal reflection will take place at this surface or not. As you can see, I have drawn the normal here. This angle, if this is 60 degree, the angle of reflection, it also must be 60 degree. This is 90, then this is also 90 degree. Now in this quadrilateral, suppose I give it some name, this is D, this is E and this is F. Now in this quadrilateral B, D, E, F, the sum of the four angles, it must be equals to 360 degree. It is 90, 90, 90 plus 90, 180, 180 plus this whole angle, that is D, E, F. I write it here, D, E, F. It is equals to 120 degree. And both these angles, they are 90 plus 90, 180, 180 plus 120, 300. So this part, that is angle B, F, E, it must be equals to 360 minus 300, that is 60 degrees. So this angle, we got this angle, that is 60 degree. And the rest part, as you know, this is perpendicular, this is normal. So this part, it must be 30 degree. Now this is our incident ray and it makes an angle of incidence of 30 degree. Obviously it is less. In this part, in this case, the angle of incidence here is less than the critical angle, that is less than 42 degrees. So it will be refracted. So this was about the total internal reflection in a right angled prism, that is of 30, 60 and 90 degree. I'll tell you the cases when total internal reflection will not take place. It's very simple, 30, 60 and 90. Now if the light rays, in this case the light ray, it was entering the prism through the surface BC. If the light ray, it enters the same prism, 30, 60 and 90 prism, through this surface or through this surface, then total internal reflection won't take place. And you can find the angles of your own. It's very easy, very simple part it is. If the light ray, it enters through this surface, then I'll do one part for you. The second part, you'll do it of your own. It enters the prism through this surface AB. This is 90 degree, so this must be 90 degree. this is 30, this is 90, so this angle it must be 60 degree. Now again we draw the normal so that we can get the idea whether total internal reflection will take place or not. So this angle, the angle of incidence here, it must be 30 degree, and as you can see here, the angle of incidence in this case, it is less than the critical angle, that is, it is less than 42 degree, that is for glass. So obviously no reflection can take place here, no total internal reflection will take place here. In fact, it will move away from the normal and refraction will take place. The next case for it, when total internal reflection will not take place, it will be when the light ray enters through this phase, that is through AC. You can do it of your own. Now this was all about total internal reflection in a prism. Now one more thing, you might be asked about the reasonings. Suppose that you are asked that why does the crack in a glass surface appears to be shiny. Suppose this is a glass surface. Suppose it is a window pane or anything that is made up of glass. There is a crack in it. I'll draw the crack. Suppose this is a crack in it. This is a crack in the glass surface. Then obviously if this is a crack, then the gap that is in this crack, it must be filled with air, because this is a crack, and in this crack there is no glass, there is no medium, so this crack it must be filled with air. I'll mention it here. This gap inside the crack, it is filled with air. Now what will be the condition? The light ray, it has to travel from, obviously this whole part it is made up of glass. So now the light ray has to travel from glass to air. This is our surface of separation. I'll make it bold. This surface. This is our surface of separation. That is separating both the mediums, glass and the air inside the crack. So now, if the light ray, it has to travel from denser, that is from glass to air, that is inside this crack. So now it will, if it strikes the surface of separation at an angle greater than the angle of the critical angle, if it strikes the surface and makes an angle of incidence greater than the critical angle, then total internal reflection will take place. And that is why this crack, it appears to be shiny. It shines like a plane mirror.